A queue can save your API, but still break the product. Fast checkout, duplicate receipts, stuck work. Follow one checkout. Payment is synchronous. Receipt, inventory, fulfillment, webhook, and analytics move behind the queue. The senior question is simple. What second timeline are we creating, and how will we prove each job finished safely? Before the queue, everything runs inside the request. The user waits while the system sends email, updates inventory, calls a third-party webhook, and records analytics. The first useful move is to keep the payment decision synchronous, then publish the follow-up work as jobs. The API returns after the critical work is accepted, not after every side effect has finished. That improves user latency, but it creates a second operational timeline. Now you must know what was enqueued, what was processed, what is retrying, and what is stuck. A queue message is not just a blob of JSON. It is a contract between the producer and the consumer. What happened, who owns it, what version it uses, and what makes it safe to process. The most important field is often the idempotency key. If the same receipt job appears twice, the consumer must be able to say, I have already completed this outcome. Ownership matters too. If checkout publishes version 2 of an event, and fulfillment only understands version 1, your queue has become a delayed integration failure. Most practical queue systems are designed for at least once processing. If a worker crashes or times out, the message can come back. That is useful, but it means duplicates are normal, not exceptional. A production consumer records progress around the business outcome, not around wishful thinking. Charge once, send one receipt, apply one inventory adjustment, even if the job is delivered more than once. The visibility timeout must match real processing time. Too short and healthy jobs get duplicated. Too long and failed work waits silently while customers wonder what happened. Some jobs will never succeed without a change. A bad schema, a deleted account, a missing fulfillment mapping, or a third-party response your code does not understand. A dead letter queue is not a trash can. It is evidence. It gives operators a place to inspect failed work, classify it, repair the cause, and decide whether replay is safe. Replay is not a button you press to feel productive. Before replaying, confirm the consumer is fixed, the operation is idempotent, and the customer-facing state will not be made worse. Queue depth by itself is not enough. A queue with 10,000 fresh jobs may be fine during a planned batch, while a queue with 200 old jobs may be a customer incident. Oldest message age is often the sharper signal. It tells you whether consumers are keeping up with the work the business already promised to finish. When pressure rises, you can add consumers, reduce producer rate, split work by priority, or shed non-critical jobs. The wrong answer is letting the queue become an infinite hiding place. Ordering is not a default technical preference. Ask what must be ordered. All checkout events globally, one customer, one order, one inventory item. The answer changes the design. A common answer is partitioning by entity. Events for the same order use the same key, so related work stays sequenced, while unrelated orders can still process in parallel. If publishing the message and committing the database change can disagree, use the outbox pattern. The database records the state change and the message to publish in one transaction. A queue system needs a signal stack: producer rate and queue failures, consumer success rate, retry count, oldest message age, dead letter rate, and customer visible completion time. Recovery should be boring. Replay in small batches, keep the dashboard open, stop on unexpected side effects, and preserve the evidence of what changed. If only one engineer knows how to drain the queue, the design is not production ready. The runbook should explain alerts, ownership, safe replay, customer communication, and rollback limits. The stronger architecture is not just API, queue, and worker. It is producer contract, durable queue, idempotent consumers, retry policy, dead letter review, backpressure signals, and safe replay. Use the same judgment loop every time. Move only the right work off the request path. Define the message contract, make consumers duplicate safe, observe the backlog, and prove recovery. Before adding a queue to your next system, ask this: if the job runs twice, runs late, or never runs at all, where will we see it, and how will we repair it safely?